In lesson 5.1, we're moving into linear equations. This whole chapter is going to talk about linear equations. And one of the first things that you need to remember, you did this last year with linear equations, is your rate of change, which is also your slope. And the way you can look at rate of change for a line is a change in your dependent variables, which are your y's, divided by a change in your independent variables, which are your x's. And the word change should mean to you finding a difference or subtracting. Go ahead and write that down, and when you're ready, hit play again. We're going to look at different ways of finding rate of change. So the first way we're going to look at is finding rate of change using a table. Go ahead and copy this table down, and once you're done, hit play, and we'll go through it together. So when you go to find your rate of change, all you have to do is look at any 2 points in the table. It doesn't matter. You can pick 160, 5, and 120. You could pick 4, 105, 5, and 120. 2 with 75, and 4 with 105. Any variation you want, it doesn't matter. Everyone should end up with the same answer at the end. So I'm just going to go ahead and pick 1 and 60, and 3 and 90. And now what I'm looking at is the change in my dependent variables, which are my y's, over the change in independent variables, which are my x's. I prefer things to be positive when they can, so in this case, when I go to look for my change in my y's, I'm going to choose 90 minus 60 versus 60 minus 90. But either one will work, and I'll show you both just so you see how that works. So, the points that we're picking are 160 and 390. And then you're just going to set this up as a fraction the way we just talked about. Remember, y's go first because it's your dependent first. So I'm going to go ahead and call it m equals. Hopefully most of you remember m from last year. M represents slope. You can go ahead and add that over here. That's a letter we used for slope. Pick any 2 points. To find the difference. So now I'm going to go ahead and find my difference here. 90 minus 60 divided by, because I chose 90 first, I have to choose 3 first. 3 minus 1. And once I do that, I get 30 over 2, which is 15. So my rate of change here is 15. And notice it's about a cost, which means that for each day, it's going up $15. So, m equals 15, which means the cost goes up 15 per day. Now, I'm going to show you just so you can see how this works the opposite way, because I want you to see that it really doesn't matter which point you're choosing, which y value you're choosing first. All that matters is whichever y value you choose first, your x also has to be first. So if someone else had picked to put 60 first, they would have had 60 minus 90 over 1 minus 3. Because remember, you have to use the same point first. And they would have had a negative 30 divided by a negative 2, which is still a positive 15. So they would have ended up with the same rate of change. It didn't matter. And that leads into the formula that you're going to use to find slope when you're talking about it as an actual formula. After I'm done talking about this, go ahead and copy it down and then hit play and we'll go over it. But what I'm saying here is your second example is just finding a rate of change, same thing as before, but you have a graph instead of a table. you're going to do the exact same thing because you're trying to find the exact same thing. The only difference is you're going to get your 2 points from your graph instead of from a table. And this right here represents all the different points that are available to choose from. You always want to choose a really easy point on those. So go ahead and copy that and then hit play when you're ready. Alright, so when you look at this, one point that would be really easy is to start at 0, 1500. Another point that would be really easy is 180, 0. All these points in here, you have to be careful because your graph has to be so perfect and you're estimating, so you have to be very, very careful if you were to choose something like that. So always pick something that makes a lot of sense to choose. Now my graph wasn't perfect, but there's also a point that crosses through 120 and 500. And I know that that works because I looked at the graph that was the actual graph that was easy to read. So I went ahead and put a dot there also. At this point you now have 3 points you can choose from. I like to keep my numbers smaller when I can, so we're going to go ahead and use these 2 points. So you pick your 2 points. Remember, you're always finding change in y before you find change in x, which tends to get confusing. So the points we picked are 120, 500, and then 180, 0. And that's why I always underline the y's, because it reminds me 2 things. Number one, it reminds me they go at the top of my fraction in my numerator, and it also reminds me to go ahead and use those first. So now, just like we talked about a minute ago, your choice. You can choose 500 minus 0 or 0 minus 500. Doesn't matter. M equals, I'm going to go ahead and choose 500 minus 0 over 120 minus 180. Remember, you have to choose the same x first that you chose the y first. So I end up with 500 over, be careful here because this actually ends up being a negative 60. And that makes sense because if you notice, the plane is dropping down as it's landing there. So it makes sense that we would be going down, not up, with that negative there. And once you look at that, the way to simplify that, you can go ahead and simplify it. You end up getting negative 25 over 3, because 20 went into both of them. And then you can also write that as a mixed number, which would be negative 8 1/3. Either of these would be acceptable answers. That you need to simplify. Okay, most of you remember this formula from last year, but we're going to go ahead and write it on the left side of our notes now, and you've been using it when you've been looking at your rate of change, but this is just the official formula that goes with it. So the formula is m equals y2 minus y1 over x2 minus x1. And here's the important part. This is not a y squared and then a y to the first power. This is like, it's basically labeling it. It's just saying, hey, whatever x I choose to be number 2, the y needs to also go there. Same thing here. And so you're just proving that you're lining up those same things. If I choose this one first, that one's going to be first also, which is why these each have a 2 with it. And these each have a 1. I have no clue why they don't just have y1 minus y2. It really doesn't matter because you can take these points and you can flip them around, and this point could be y1 for someone and x1, and the other person could have this as their y2 and their x2, and you're still going to get the same solution, the same slope in the end. So don't spend a lot of time getting confused about those. Just think of them as a way to name it. And then that's kind of what they're showing you here when they write the points, x1, y1, x2, y2. Again, just showing whichever one I choose to be my y1 needs to have the same x1. So they're going to line up under each other in that fraction. And you've already been using that formula right here. Notice y minus y over x minus x. Another example we're going to talk about is finding your slope on a graph where you maybe haven't even been given points and asked to, and they might not say find rate of change, they might say find slope. It means the same thing. You can always use the formula that we just talked about. Pick 2 points, plug them in, find your slope. Or you can use, again, this is a review from last year, rise over run. There are several different ways to use this. I really want you just to go ahead and try using it my way this year, because it's a lot easier to understand when I'm talking about it in class if we're all using the same thing. Someday you're going to be able to use whatever way you want that was your favorite of what your teachers taught you throughout the years. But for this year, we're going to go ahead and follow the rules that I'm going to give you during this example. So copy this down, and I'm going to go ahead and draw out the graph, and then you'll be able to copy that down also. So go ahead and draw this graph out. Just make sure, what I went ahead and did just to make it easier for us, even though you're not always going to have points plotted on these lines, for purposes of us being able to graph it and go over it a little bit easier, I went ahead and said just make sure that you have -2, 1 in there and 3, 4 in the graph that you draw. So draw that out, and once you have that drawn out, you should end up with a line that crosses through those 2 points. And it's hard for me to reach under this and draw it, so I'm going to hit pause and draw that in too. You should have a line drawn in, and it should be crossing through the point -2, 1. Sometimes you can find a really nice point that it crosses through. You don't ever want to find a point where it's like right here, because you really don't know what number that is exactly. So you want to find them pretty exact, and this is when graph paper really starts to come in handy. So you should probably have some graph paper to use. And now you have 2 options from here. You've got 2 points, so you can use the formula we just talked about. y2 minus y1 over x2 minus x1, which we're going to do that. Or you can use rise over run. So we're going to go ahead and use rise over run first, and then we'll prove that we got it right using the formula. So what you want to do with rise over run, and this is where everyone has a different way of doing it, but I really want you just to try it my way this year so that I understand what you're trying to do and you understand what I'm saying when I'm doing it in class. So rise over run, you always deal with your rise first, which is your change in your y-axis. And you're always going to look and say, okay, to get to the right of this graph, do I have to go up to go right, or do I have to go down to go right? That's going to determine if you have a positive or a negative slope. It's easy for me to remember up is positive, down is negative. So I'm looking at a point, either point, and I have to decide, would I go down and right, or would I go up and right to get to another point? And in this case, we're going to go up and right, which means it's a positive slope. So m equals, I already know I've got a positive slope now. Now what you're going to do is you're just going to count your change in your y's. So you count up, there's 1, there's 2, there's 3. Before I got to the next point that I'd already identified, I went up 3. So positive 3. And now I'm going to go over to the right, and you always run right, RR, run right. And I count out the same way. There's 1, there's 2, there's 3, there's 4, there's 5. You count till you hit the dot. You don't count the dots as 1. You count from here to here as 1, 2, 3, and from here 1, 2, 3, 4, 5. So my slope is a positive 3/5. This is my rise, and we went up over my run, and we always go right. Sometimes you're going to have to go down to go right. That gives you a negative slope. So let's go ahead and try it with the formula based on the 2 points we looked at, just to prove that we know how to do both. And our formula, remember, we write our 2 points down. We have -2, 1, and we also have 3, 4. Underline your y's, those are the first, and then decide, do I want to have 1 minus 4, or 4 minus 1. And I would probably choose 4 minus 1 because I like to keep it positive when I can. So I have 4 minus 1 over, because I chose 4, I have to choose 3 first. Be careful here with evaluating. It's 3 minus a negative 2. It's a really big mistake that students make every single year. And then you would rewrite it, 4 minus 1 over 3 plus 2, and you end up with 3 over 5. So exact same slope both ways. It does not matter. As long as you're doing the math correctly, either one is going to get you to the correct slope. Go ahead and fill that in on the left side. It's just talking about what we talked about. You always are looking to run right. And if you're going to go up to run right, then you have a positive slope. If you're going to go down to run right, then you have a negative slope. Write that in, hit play when you're ready to start again. The last thing we're going to talk about in this lesson are two special types of lines that you're going to come across, and that is horizontal and vertical lines. And you have to figure something out that's going to help you to remember this. So I'll tell you what helps me, and maybe some of you can come up with something that helps you, and if you want to share it with the class, you can. But it's very easy to confuse, so you really have to make sure that you memorize which one goes with which line. The first thing we're going to look at is horizontal lines. Remember, a horizontal line is a horizon. It's on a horizon. It's going to go across your paper from side to side. So I'm going to go ahead and put my line in a different color so it's kind of easier to see, because it ends up looking like the axis. That's what happens with these, so you might want to mark some spots on your axis too. And that kind of helps you to see those. So I went ahead and put my horizontal line here on 2 for the y-axis. Think about chapter 4. Do we have a function here? Is there one y value or one x value that never repeats? Do we have any repeating x values? And that's where it can get a little confusing. We have tons of repeating y values, don't we? They go forever. Every single x value has the exact same y value. But there's no repeating x's, so this actually is a function. Okay, so horizontal lines are functions. And I'm just going to go ahead and show you why the slope is what it is, and then we'll just memorize it, hopefully, so you won't have to do this every time you see these. You can memorize this. But if I was going to find the slope of this, I just need to pick any 2 points. So let's say I'm going to pick this point and this point. So I have the point 1, 2, and I have the point 2, 2. And then I'm going to use my formula. And my formula is 2 minus 2 over, doesn't matter because I picked one of those, 2 minus 1, which ends up being 0 over 1, which equals 0. So when I look at this, I've just memorized that my slope every single time I see a horizontal line is 0. And if you forget, you can always pick 2 points and see what happens. Remember, you're allowed to have 0 in a numerator, you just can't have it in a denominator of a fraction. And the way I think about this is 0 slope. If I was riding my bike on a really straight street, then it's just 0 slope. I'm not going uphill, I'm not going downhill, it's just 0. I'm not gaining positive or negative. Okay, now let's look at vertical lines. Vertical lines are the lines that go up and down. So let's go ahead and make our vertical line right on 3 on the x-axis. So that is my vertical line right there. And now we can do the same exact thing to find the slope. We pick any 2 points. So maybe we pick this point and this point. And we end up with 3, 1. And we end up with 3, negative 1. Remember, it does not matter here. Does not matter which points you're going to pick as long as they're on the graph. So I underline my y's, and I get 1 minus negative 1 over 3 minus 3. This becomes 1 plus 1 over 0, which is 2 over 0. And really, once I saw 0 here, I could be done. I don't have to go any further. Everyone knows can't have 0 in the denominator. So as soon as I see that 0 in the denominator, I'm not going to say a slope of 0, because 0 is a number that we use in math. I'm going to say no slope. There's a difference between giving me an answer that says no slope and giving me an answer that says 0. So be really careful with that. As soon as you see that 0 there, no slope. And I think about that because there really isn't a slope. It's not gaining slowly or declining slowly, and it's not just staying at 0 across. It is straight up and down. There is no slope there at all. It is just going straight up and down. I wouldn't want to be riding my bike on that. This, notice for x we have tons and tons of different values for y. Repeating x's, not a function. Okay, we're still going to learn to graph them this year, and we're still going to learn to deal with them. Even though I said most of the year we're only dealing with things that are functions, this is one of those special cases that you're still going to learn about, even though it's not a function. And that's the end of lesson 5.1.